Hello, let's do the New York Times Hard Sudoku for September 26th, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, in this box we have 1679. This one and this one look into this box, putting a 1 in one of these two cells. I was looking at 1 in this column, because this column's almost filled. But it can go here or here. Let's just look at this column in general, though. It looks tempting. So we need a 1, 5, 8, 9. So what can we do with that? I think everything sees at least one thing. Some of them see quite a few. So if I do 1, 5, 8, 9, we see this 5 in this box takes the 5 out of both. And then we have this 1 and 9 taking 1 and 9 out. And then this cell sees 1, 8. Unfortunately, this sees nothing. So we'll leave these marked, nice buy value cells to start us off with. Let's go back over to here though. So that was the 1. 1 is also placed in this box vertically. 2 1s look down, putting a 1 in one of these two. I was looking for 1 in this row, but there's nothing restricting it. All right. That was the 1. 6. I don't think there's anything to do with 6. Not quite, nope. 7. 7's looking through here. 7 looks up. So 7's one of these two. We have 2 7s vertically, putting a 7, excuse me, somewhere over here. This 9. Really don't see anything to do with 9. All right. We have 3 and 5 over here. So, anything? Well, we do have these 2 5s. What's a 5 in one of these two? I think that's all we get out of that. And we've got the 2, 4, and 5. So we do have these 2 2s and then these 2 2s. So 4 of a digit all looking into a box automatically places that digit. But there's also usually not a whole lot you can follow up with, at least not directly. There can be indirect consequences, of course. But, vertically we have all the 2s. Horizontally we have all the 2s by definition. All right. So that was the 2. We also have 2 2s looking up here. So it's a 2 in one of these two. And 2's in one of these two in this box. Sorry, I'm going to drink some water. I usually try not to. Apologies. All right. That was 2, 5, and 4. Let's get this 1, 2, 4, 7 here. First thing that immediately strikes me is anything in this column or this row is really interesting because it eliminates from 3, and we'd end up with 2 left here if it was vertical or 2 left here if it was horizontal. The only thing I'm seeing is the 8 because the 1's already placed and the 2 is already placed. But the 8 looks in, putting an 8 in one of these 2 cells. And that does point. Now, points down, this 8 looks in, so 8's one of these, and it looks up here, so 8's one of these 3. But I can't quite do anything with that yet. But this is something we're going to have to try to remember as we have these pointing 8s. The corner marks try to help us with that, sometimes more successful than other times. I do have 2 1s here, putting a 1 in one of these 3. I have this 4 and 7s. Okay. 7 is placed in this box. My goodness, I'm sorry. Something irritating my throat. All right, this 5 looks down. These aren't 5. Puts the 5 in one of these 2. That points down along with this 5. Putting a 5 in one of these 3. All right, anything else looking in here? The 1, 2, and 7 are placed. The 4 is not. So 4 is in one of these 2. That points in here along with this 4. This 4 looks down. That's not a 4. So that 2 had an effect. That's kind of the indirect effect I was talking about. Because had we not placed that 2, 4 could have been one of these 2. But after noticing this 2 got placed, even though there wasn't a direct follow-up, now there's only one place left for 4 in the box, and we can place it. These 4s, put a 4 in one of these 3. I mean, I guess we didn't really need this other 4, but... This row is now down to 4 digits. We need a 3, 5, 6, 9. I'm seeing a 6 and a 9 here and a 3 here. So if I write out 3, 5, 6, 9, this can't be 3, 6, and this can't be 9. This can be any of them, as far as I can tell. But that does make a 5, 9 pair here. So 5, 9 pair removes 5 and 9, or another way to put it is, where do 3 and 6 go in the row? They go here. Does that help anything? Well, this is now 5, 8, 9, which could be helpful. All right. This box is down to 4 digits as well. We need a 3, 4, 5, 9. So we know that these aren't, so this isn't 4 or 5, so this is 3, 9. I don't see any 3 9s looking in here eliminating, so all of these are just the corner mark plus 3, 9. So 3, 9 plus our corner mark, 3, 9 plus our corner mark. So that means this is down to 4 digits, 3, 4, 5, 9, all of them. So we're not going to mark it. I do believe that's all I'm seeing. Okay. Anything else to do in this band? No. Let's move on to the last band here. We do have 2 3s. This 3 helps. Puts a 3 in one of these 2. And we have 2 2s. This 2 helps. Puts a 2 in one of these 2. Oops. I meant to quarter mark both of these, and I somehow didn't even look at what I was doing for those 3s, but we have fixed it. 8. All right, I believe that is it for our initial scan. This is a filled box column. Okay, so I did miss one thing. This is a filled box column. So we want to look at these 2 columns to see what hasn't been placed yet. So these givens. And so the 2 has been placed. The 4 we've already marked. But this 5 looking down does put a 5 in one of these 2. And that's going to point in here along with this 5, putting a 5 in one of these 2. So for here, we want to look for 5 in this row. It can be in any of these. And then for this marking, we want to look for 5 in this row. It can be here or here. Okay. So I do believe that does conclude the initial scan pass. We got some good stuff, but not a whole lot in this band or in the top or bottom band. So what I'm going to do is my next pass that I do, I look at every single row. And what I'm looking for is, do I have a pair or triple that I might have missed? It doesn't look like that's going to happen today. And are there 4 or fewer open cells, or in general, do some cells just look like I should try to pencil them? And if so, I will try to pencil them and see what happens. Basically, I pencil if there's 3 or fewer open cells, or sorry, 3 or fewer possible digits in that cell. So that row, that other. I really don't think I'm going to find anything in the rows today. I'm going to look at the columns. I do pay less attention to the columns in my initial scan, so I'm more likely to miss something. I am going, since we're a little bit desperate and there's not much to find, I am going to look at this column and this column, which have 5 open cells. It's a lot harder for me to remember 5 digits versus 4, but the 5 digits left here are 3, 5, what did I miss? 2. 2, 3, 5, 6, 8. See how that's just like that one extra just makes it so much harder. 2, 3, 5, 6, 8. So we know these aren't 2 and they aren't 3. And so these are down to 5, 6, 8, and this one's not even a 6. So as soon as I mark it, what I'm looking for is, did I make it maybe a triple or pair in the column? Did I make a pair here or a triple here? Right? You just want to scan it, because when you mark something is the most opportune time to find buddies for it. So this, remember that it was 2, 3, 5, 6, 8. This can't be 3 or 8. So this is 2, 5, 6. And this can't be 5 or 6. So this is 2, 3, 8. Now, something I did notice is 5 was eliminated from both of these, right? This isn't 5, and this isn't 5. The only reason this isn't 5 is because we had that hidden 3, 6 pair in the row, or the 5, 9 in the row. But it is not 5. And so the 5 ends up down here, and this is going to do something called claiming. Could have noticed these 5s lining up as well, but I did not. Now, the way claiming works is we look at this column here, and we say it's going to need a 5. Well, where's that 5 going to go? It's going to go in one of these 3 cells. Whichever cell it ends up in, it will also be in this box, box 7. And so, as a result, we know since there's a 5 here, or there's a 5 here, or there's a 5 here, the column dictates that, there cannot be a 5 elsewhere in the box. So it eliminates 5 from all of these cells. And I think that segues into actually looking at this column with that knowledge that these 2 can't be 5. So We need a 1, 4, 5, 8, 9. 1, 4, 5, 8, 9. So we know these aren't 5. So I'm going to write out 1, 4, 8, 9. This can't be an 8. Is there anything restricting this? Not that I can see. Even though it can't be 5, I am going to not pencil it because it is 4. And the more cells you have penciled that aren't useful, the harder it is to find the ones that are useful. Speaking of, I should make sure none of the things I penciled so far are helpful. All right. And now up here, okay, I have to rethink about what it was. I already forgot. We need 1, 3, 4, 5, 9. So we know this isn't neither of these are 9. And this isn't 3, 4, this isn't 5. So remember, it was 1, 3. Oh, they're not 1 either. Oh, wow. Sorry, 1, 3. This isn't, oh, the 3's in the column. So no, not 3. Let's try this again. 1, 4, 5, 8, 9. Not 1, 4, 5, 8, not 9. And that's not 5, that's not 4. Okay. That took way too long. 4, 5, 8, 9. That is not a triple, because we have 4 possible digits for these 3 cells. It's nice to find these by values. So when scanning this 4, 8, right, one question that popped in my head is, well, maybe I have a 1, 4, 8 triple in this row. It's possible. I have a 4, 8 here and a 1, 8 here. I just need one more cell that's restricted like that. So how would I find that? Well, I mean, I could just try to pencil all of these and find out, but there's kind of a quicker way to think about this without, over penciling, which is to think, well, I already have 2, 5, and 9 in the row. And if I have a cell that's 1, 4, 8, there's a couple digits that it can't be. What are those digits? Well, it would be the 3. It's basically the digits that aren't mentioned in the highlighted cells. So the 3, the 6, and the 7. So actually it's 3 digits, that not a couple. So 3, 6, 7. So if there's any cell in this row that can't be all of 3, 6, 7, then we have found our triple, because that cell will be marked as a 1, 4, 8. This already can't be 6, 7. So we just have to eliminate 3 from it, and that would do it. But unfortunately, I do not see any way to eliminate 3 from it. And that is probably our best bet. These can't be 3. Oh, here we go. Actually, I found it. That's quite nice. And actually, that's going to put the 3 there. I do believe. We'll see. Maybe not. Anyway, what am I talking about? This cell here, if we were to pencil it, it can be a 1. It can't be 2, 3. It can be 4. It can't be 5, 6, 7. It can be 8, and it can't be 9. So it is down to 1, 4, 8, and we get this 1, 4, 8 triple in the row. I did not know that was going to happen beforehand. In fact, I was pretty sure it wasn't, but this is why we look, right? Because we don't know ahead of time. And so this is a 1, 4, 8 naked triple, because between these 3 cells, we only have 3 distinct digits that can be placed in them. 4, 8 here, 1, 4, 8 here, 1, 8 here. So 1 will be used by one of these, 4 will be used by one of these, and 8 will be used by one of these, so that they each get a digit. And that's going to mean that we cannot put 1, 4, 8 in the rest of the row. And so what were the 3 digits that weren't 1, 4, 8? Well, they were the 3, 6, 7. And so that means these are where the 3, 6, 7 go. But this cell can't be 6 or 7, so it's a 3. And then that leaves a 6, 7 pair behind. Now this 3 does give us the 6 and 3 here. Oops, I typed a 9 instead of a 6. 6 and 3 here, that's not a 3. And so now eliminating the 3 from here, let's see. Yeah, so I guess the question to ask is where's 6 in this column? It was actually I didn't eliminate 3 from here, I eliminated 6 from here. Eliminating 6 from here now means the 6 is in one of these 2, and that also claims. So now we know this isn't a 6, although it already wasn't. Oh, we already have 2 6s now. Okay, but anyway, don't need to worry about claiming when we already have eliminations otherwise. This cell, I'm trying to follow up on stuff we got. We got a lot of stuff, so let's just be careful here. We need a 2, 4, 5, 8. We know it's not 8 because we have these pointing 8s up here. It's also not 4, so it's down to just 2, 5. So we actually have this, okay, yeah, actually we don't have a quad, because where does 4 go? This is 2, 5, 8 only. So this is where the 4 goes in the box. This cannot be 4 now. That can't be 4. So these 2 4s looking down do put a 4 somewhere over here. In fact, oh no, not in fact anything. For some reason I saw a triple, but it's definitely not. This is down to 1589. This can't be a 5, right? Because of the claiming 5s here. So this is now just 189. Oop. I did not mean to do corner marks. 189. Is that true? Yeah, 1589 for the column. This can't be 5 anymore. Okay. All right, what other follow-ups can I get? So this is a 1-8 pair now. We got this 6-7 pair. They aren't 1-8. See, I got this 3. These 3s look in. These can't be 3, so the 3 is right here. And that used up, remember there was a 7 corner mark in this before I placed the 3. What's really nice about Sudoku Pad is if I forget what corner marks were behind it, I can just delete it, press delete once, and that'll remove the 3, and it'll remind me that I had the 7 corner marked there. Now I now have one fewer spot for 7 in this box, which leaves just one place for 7, which is right here. So even though the row couldn't resolve the 6-7, the box actually does. It's the only place in the box we can put a 7. And so the 7 ends up right here, and then that's a 6. So we got the 7 and the 6. The two 7s look down. Now, what have we found here? This is a hidden pair. What that means is one of these two needs to be a 5, and one of these two needs to be a 7. Well, if one's a 5, that means the other is the 7. So we end up with a 5-7 pair here. That means this is a triple. It always has been. Well, at least now that we've placed the 7, it has been. We need a 1, we need a 4, and we need a 9. All right, so this can't be 1 anymore because of the 1, 4, 9. This is a triple as well. We need a 3. Top one's not 3. We need a 6 and a 9. That's not 6, that's not 3. So the 3 ends up in one of these two, which is going to claim. We don't really care, though, because we already had these 3s. This is in this box is down to 1, 6, 8, 9, but not an 8. So it's 1, 6, 9. Okay. So we know the 6 is one of these two. I don't think that does anything. 1, 8, 9. We know the 8's in one of these two. That does mean... Wait, where does the 8... Did I mispencil these? Did I miss the 8? Yeah, okay. So I'm going to go back to when I penciled this because I penciled it wrong. I need to be more careful. I said 9, but I should have said 8. So these are down to 3, 6, 8. That's not 6, that's not 3. This is, in fact, if we look, yeah. Okay, never mind. Not if we look, but before I didn't have anywhere to put 8 in this box, and I was very confused. It's because I penciled the 9 instead of the 8. So this is down to 1, 6, 8, 9. We know it's not 8. So this is 1, 6, 9. And that still puts the 6 in one of these two. All right. Now we do not have the pointing 8s here because this can be 8. What is kind of the lowest hanging fruit here to pencil up? This column is down to 1, 6, 9 because we have the 5, 7 here. This can't be 1 or 6. So this is a naked 9. It can only be 9. It can't be 1, 2. It can't be 3, 4. It can't be 5, at the very least because of these claiming 5s over here. Is there any other reason it can't be 5? I don't think so. I think it's just the claiming 5s. But yeah, it cannot be 5. Can't be 6, 7, 8. So it is down to just a 9. Oh, the 5, 7 pair took out the 5 as well. Okay, anyway, that's a 9. So that's only 5 now. That's 9. Resolve the 5, 9 for this row. These can't be 9 anymore. So that's a 5, 8 pair. So this can't be 5 anymore. So that's a 2, 8, and 5. That's a 9. All right, down here, that's not 5. That's not a 9. That's not a 9. It's not a 2, so this is the only place for 2 now. Here we get 1 and 8. Here's 5 and 6. Here's 2. That's not a 2. All right, it's not a 5. We get the 7 and the 5 here. That's a 5. 4, 7. What's the other digit? 9. Okay. This row's down to 2 digits. 1, 2, 3. We need a 4 and 7. This 7 tells us the order. That's 4 and that's 7. This box needs a 1, 8, 9. So that's 1, 9. This is 8, 9. I really don't need the corner mark there. I don't need this corner mark. All right, this box is down to 3, 4, 5, 9. Not a 9. So 3, 4, 5. Where am I looking? How about this column? We need a 1, 1, 8, 9. Only thing I see is that's not an 8. 1, 4, 8, 9, not an 8. 1, 4, 9. What is it that I'm missing here? This row, 4, let's see. Yeah, 4, 6, 7, 9. The 6 can only go here in this row. Also the box. Either way, however you want to do it, the 6 got placed. We don't actually have all our 6s yet, though. Well, this is 1 or 8. Okay. 1 or 6. Is there something I'm missing? This is 4, 7, 9, not a 7. 4, 9. I mean, this is a 1, 4, 8, 9 quad. Basically, the hidden pair in here. What's the other digit? The other digit's a 7. So this is a 3, 7. Oh, this is actually... There's only one place for 7 in the box. That's the easiest thing to see. And then now there's only one place for 3 in the box. These cannot be 3s. That's not a 7. 4, 9 pair, that's our 7. 7s are done. All right, so everything's penciled. I must be missing something obvious here. Yeah, 8 in this box can only go here. These couldn't have been 8. That's our 1, 9, and 8. Gives us the 6, 1, and 8. Gives us the 6, 1, 3, 8, 3. Here's the 4, 5, 5, 9. Here's our 5 and 8. Here's our 4, 1, and 9. Here's our 9, 4, and 1. Here's our 9 and 4, and we're done. Oh, that took me some time. Interesting. It felt like I was flowing, but I did get a little stalled in the middle. Cool. Well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.